Welcome back to our Unit 4, Chapter 7. We're going to continue on with Section 4 in that unit. Here are our targets for today. To complete this lesson, I will be able to use inverse properties of logarithmic functions to simplify the expressions. We're going to use inverse properties of logarithm functions, logarithmic functions to find the inverse of a logarithmic function. And we're going to use a calculator to evaluate logarithms. So hopefully you can read and write those down better than I can say them, apparently, and have them ready for tomorrow. Okay. Inverse properties of logarithms. Rewriting logarithmic properties. So to undo logarithms, basically, or exponential functions, and vice versa, if you have a logarithm of the same base as the exponential functions and you put them together, they cancel out and the exponent is all that remains. Similarly, if we have an exponent or a base b raised to the power of log b of x, the logarithm and the base cancel each other out and we're left with just the x value. So these properties are going to be helpful in us solving equations and simplifying expressions. And like it says down there at the bottom, they look complicated, but they're not as bad as it seems. So using these properties, let's evaluate and simplify some expressions. Let's look at number 1. 8 log base 8 of x. 8 to the log base 8, we use the property here. It cancels out. We're left with just x. This one, 7 to log base 7, is just negative 3x. The 7 and the log base cancel each other out. Let's look at 3 and 4. Log base 3 of 3 to 2x, the log base 3 and the 3 cancel out. We have just 2x. And now we're going to get a little complicated down here. Say, oh, that's not going to work, Mr. Kuhn. Number 4, that doesn't cancel out directly. But we can rewrite 4 as a base 2. We can rewrite it as log base 2 of 2 to the second power times x, or log base 2 of 2 to the 2 times x, and reversing our exponent rules. Log base 2 and the power of 2 cancel out, and I have just 2 times x. Log base 3 of 9 to the 2x. Can I rewrite 9 as a base of 3? Log base 3 of 3 squared. I think that's what 9 is. But it's going to give you guys some time to think about it. And then that's just log base 3 of 3 to the 2 times 2x. The log base 3 and 3 cancel out. 2 times 2x is 4x. And of course, can't forget about natural log and natural base. They have the same base, they would cancel each other out when they get close to it. So those using the inverse properties to simplify expressions. We can do some more of that here, and I should say tomorrow when we start in class. Okay, real quickly, this is an additional, this wasn't one of our main goals for the lesson, but if you ever do have to graph a logarithmic equation, we're going to look at number 2 here. Your graphing calculator can do it for you. So write down the equation y equals log base 1/3 of x minus 3. I'm going to show you how to put it in your calculator real quick. So we type in log, or if you hit alpha and you hit window, you see some choices here. We're going to pick number 5, which is the log basis. When I choose that, I can type in 1/3. Y equals, make a fraction, just because we can. I could do 1 divided by 3 in parentheses if I want to as well, and x minus 3. And when I hit graph, it gives me a picture of the graph. Notice up here, it says the graph has a vertical asymptote at which x equals h. In our equation here, h is positive 3, the opposite. What makes x minus 3 equal 0? If we look at our graph, you can see that that graph does not cross that line. So you can identify the domain, you can identify the range. The domain, it's all the x's to the right. So our domain would be x is greater than 3. And our range would be all values, well, how high does it go? Looks like it goes up to, we can go to our table to help us with that as well. If we go to our table, it looks like our biggest output value is when we get between 4 and 3. Looks like it goes maybe up to 2. So our range is all x less than 2. Right? And the asymptote, of course, is x equals 3. So that's just a way to graph money calculator and get the picture. Just a little extra bonus coverage for you on this problem. Okay, so now let's find the inverse of some logarithmic and exponential functions using our inverse rules. So first thing, remember about finding inverses in general, we have to switch x and y. So the first step is to switch x and y. Then, our second step is to solve the new equation for y. So those are the two steps we're going to follow to solving each of these equations. So let's take A, and let's move it down here. And we have y equals 4 to the x. Move the B down as well. Y equals 4 to the x. So we have to switch x and y. So that's our first step. Switch x and y. So this becomes x equals 4 to the y. Second step is solve for y. How are we going to get rid of a exponential base 4 from that side? So y is by itself. Well, we're going to use our exponential logarithmic inverse rules. And what we're going to do is we're going to take the log of base 4 to both sides of this equation. On the right side, the log base 4 and the base of 4 cancel out, and we end up with y equals log base 4 of x. And that is our answer. Some people have to write it with the y on the left, either way, same thing. So this is our answer, either way. Okay? So use your inverse logarithm rules to isolate the variable. Over here, what if it's a logarithm? We do the same thing. We switch x and y. So x is here, y is on the left. We do x equals natural log of y minus 5. So the y minus 5, that's in parentheses. If it weren't in parentheses, we would subtract 5 from both sides. But since it's in the parentheses, we have to work outside in when we're solving. So how do we undo the natural log on both sides? Well, we're going to use the base e. And we use the base e, and we're going to raise each side up as an exponent. You can do that. And why do we want to do that? Well, the e to the natural logarithm part will cancel out, and we end up with y minus 5 on the right, and e to the x on the left. Now I still want to get y by itself. Add 5 to each side. We end up with e to the x equals y, or y equals e to the x plus 5. Oops. Forgot the plus 5 part. Let's bring it out the right way. E to the x plus 5. That's it. Now we have it. So we can use those properties to find inverses as well. So I believe we hit our goals for today. Use inverse properties to simplify expressions. We use inverse properties to find the inverse of a logarithmic function. I believe we used a calculator yesterday to find logarithms, so that's an old target. We also added on graphing, how we can use the alpha key and the window button to find the log base key and put equations in and graph them on the calculator. So have your notes ready for tomorrow to be checked, and we'll have an assignment to work on in class. Have a good evening.